In this presentation, I'm going to show some basic advice for IoT security, and particularly in securing the full ecosystem. You'll learn a bit about risk analysis, a bit about threat modeling, and see how easy it can be sometimes for an attacker to compromise the entire ecosystem. First off, I am contractually obliged to mention that I am here by the grace of my wonderful employer Pentest Limited, who are part of the Shearwater Group. Pentest was founded in 2001. They've got a highly sophisticated offensive security team, renowned for our consultative approach, elite capability, and customer care. That's the marketing department. Did I do that bit right? Marketing says yeah. Right, so we're going to move into the talk now. Some people like to know what's coming up, so here's the plan. I'm going to overview risk analysis. This is going to explain you basically the right terms to be able to understand risk. Then I'm going to show some common vulnerabilities briefly in the IoT ecosystem. Then I'll introduce our fake product and show a simple threat model for it before moving into the live hacking demonstration, which I'm sure you're all excited about. Then a little bit at the end of how do we solve the security challenges. This slide here shows traditional risk analysis. So for decades now, a CIA model, confidentiality, integrity and availability, has been sufficient for understanding InfoSec risks. Confidentiality, ensuring that an attacker cannot access data that they should not be able to see. This one's implicit. You don't want someone else to be able to see your personal information. If an attacker can breach the confidentiality of data, then there's a chance that fines will be levied under GDPR legislation. Integrity, ensuring that an attacker cannot change data that they should not be allowed to. Also, if an attacker can execute commands on a device, then the integrity cannot be trusted because they could literally circumvent any controls the machine has. Availability, ensuring an attacker cannot prevent legitimate access to data by authorized users. So you hear about these ones in the news, such and such a website has been crashed. That's a denial of service, effectively. The CIA model has served the community well for decades. Specifically because of the risks introduced by IoT, a new pillar has been added or is being proposed to be added to the modelling. Safety or preservation of life. Because before, no matter how hard you hacked something, the chances are you wouldn't have endangered the life of a human being, or I guess, animals. And it's believed that there's a genuine risk in targeting all these new connected devices. For example, the classics would be if you interrupted the functioning of a pacemaker, you could obviously directly murder someone. If you boil a smart kettle until the point where there's no water in it and then you keep boiling it remotely, it might start a fire. Those kind of things. So there's extra risks in the IoT space that we need to be aware of. Adding the fourth pillar is how we're going to cope with it. There's debate as to whether the model is going to be CIAS for safety or CIAP. I think P is probably going to win out, but it's kind of in the works right now. Now that we know about CIAS, CIAP model, what we can do is when you're thinking about risk, is you have to determine what is impacted. Is it the confidentiality, the integrity, the availability, or a combination of these items? We have to determine to what extent the impact occurs. So is there a complete loss of confidentiality, or is there a partial loss of availability? Knowing what the extent is helps you to understand the risk. The worst case scenario is obviously completely the impact applies for every user, or it could just be one user at a time. You also need to estimate how likely exploitation is of occurring, because it could be something that would have a really high impact, but it's almost impossible to achieve. So once you have all that information, you can start to think about what is a realistic threat to your ecosystem, and then you can estimate the cost of implementing a solution. And in brutalist terms, if the cost of implementing the solution is way beyond the value of the asset you're protecting, you're not going to do it. In short, you're going to need to target your limited security budget at the highest impact and most likely threats. There's no point in wasting money where it's unlikely to be exploitable. Anyone who looks into common vulnerabilities in IoT quickly runs into these four vulnerabilities that we're going to briefly touch on here. Default or easily guessable credentials. That means that if you produce a device or a dashboard and your user manual literally says the username is this and the password is this, you're going to end up in a dictionary file of credentials and your device will be compromised. This has been a big problem in the IoT ecosystem, and things like CCTV cameras have been compromised en masse and then used to trigger denial of services against online websites. Outdated software becomes a security risk when there are known vulnerabilities in the version that's in use. Therefore, you have to keep on top of that for the device side and on any server side. Insecure communication protocols means if the device was speaking plaintext HTTP, or if it was using its own defined radio frequency transmission and it had no encryption, then that kind of thing, that's common for most devices. Non-existent updates or firmware mechanisms. Now, this one for me is key, and we'll touch on it a couple of times. Essentially, if your device doesn't have an update facility, and I'll keep harping on about this, then it can be obsoleted by a vulnerability being found by a security researcher. Almost there for the live hacking part of this. First off, we have to meet the target. So I've got a fake company here called Proactive Monitoring, and a little bit about them. We sell sensor devices with a dashboard application and alerting system. Let our system detect defects and alert your engineers. Save big dollars on maintenance costs. That's what proactive monitoring is looking for. That's what they're all about. That's a pretty common architecture though. There's a sensor device, it's doing something, it's feeding back to a dashboard, and it's triggering some sort of alert here. Here's a diagram showing that architecture. In reality, if we were making this product, obviously a sensor would be a small dedicated device for doing this. As we have limited time to prepare a demo and I'm not making a real product, I've gone with putting it into a bunch of old Android phones that I have. When you shake the phone, a vibration is detected. That issues an HTTP request over to a dashboard and the alarm is raised. Promise you that the hacking's coming. Just before, let's talk about the threat model that this architecture has. So I've chosen 3 parts of it. What you should do is take your ecosystem, break it down to as many items as you can, and then think about how each of them can be attacked. There's a physical device. In this case, I've spoofed it with a handset. But obviously, if it's a more bespoke little board, then an attacker could physically grab one and try to dump firmware, try and get serial connections to get admin interfaces. They can try reverse engineering. Those are all likely attacks if there's a physical device. Network communications, they can try and exploit the protocols. Maybe there's a bug in the drivers that are being used or whatever. If it's a sort of simple protocol, the attacker could try and just replay packets that they've captured, or they can try jamming. That means just throwing nonsense out so that the dashboard can't react. That would be a good one if our factory suddenly is not getting any alerts because you've done radio frequency jamming. Then that would be a genuine problem. So supporting infrastructure, an attacker would first enumerate the services that are on the dashboard, then they would check for vulnerabilities in the application and the infrastructure, and they can attack it just like it's a regular web application. That threat modeling was fine, but you also need to understand a little bit more, and that's around what requirements an attacker would have to be able to achieve those exploits. So for the physical device, an attacker would need to possess the item physically. They have to be able to touch it. If they do that, they can take it apart, they can try and reverse engineer it and do all those things, but they have to be able to touch it. In our scenario, if they were targeting a client deployment, that would mean accessing a secure factory, which is unlikely because there's high barriers and all that kind of stuff. It's not unheard of, but that would be the requirement. If it's a standard sort of domestic product, then they could just buy one and there's no barrier. It would, of course, impact only a single compromised device at a time because they'd have to be in the possession of the attacker. Network communications, the attacker needs to control a device on the same network. If it's using TCP/IP, that would be kind of physical access again, unless they've compromised from outside the firewall in. Where radio frequencies are used, an attacker can be near the site. They could be doing it from across the road. They could be transmitting a strong signal. The impact again would affect single or a few compromised devices at a time. The supporting infrastructure, here I'm talking about the dashboard. An attacker can target an internet-facing dashboard from any location. There's no physical access requirements whatsoever. Therefore, it's kind of the highest risk part of the infrastructure. Also, that's true because it is where all the data is fed back to. Now you're all absolutely ganting for the hacking demo, right? We came here for the hacking. There's the demo, it's coming. Boop. I am going to show you how to attack the dashboard application. This is the highest risk part of the architecture because all sensors feed back to it, compromise the dashboard, and you can do a lot of malicious things, and we will show you one of those in a minute. Here I am logged into the dashboard as an operator, and as you can see, everything is green across the board, so we have a happy little factory with no equipment warnings. I have installed the app on this phone. If we were doing this live, I would usually hand out a few of these for a bit of drama and I'd make people feel involved. When I shake this Android device, the sensor goes over its threshold. This changes the icon on the handset. It also sent that alert over to the dashboard, which triggers the alarm. The operator would now be sending a maintenance team over. Having shown it in operation, let's now move on to attacking it. Here is the login page for the dashboard. In reality, this would be available on the internet. An attacker can come across it without any knowledge of its purpose and then seek to try to exploit it. It requires a username and password before giving access. An attacker does not have this, so they'd have to gain it. What they would do is they would look for common or default password combinations such as admin for the username and password for the password. In this case, the attacker was unsuccessful. Next, they could try guessing URLs, looking for content which is not linked to from the current page. This is also a common vulnerability, and if access controls are not well implemented, unfortunately, you'll be giving access to anyone who can simply guess the URL. When looking for the /home URL, the server returned a verbose stack trace style error message. We can see from this that it is running Apache and Struts 2 as the framework. On a pen test, we would report that this style of error message has been disclosed. This is an information level vulnerability which can be easily avoided by implementing custom error handling. It has no direct exploitable weakness on its own, however it may enable an attacker to find vulnerabilities that they can exploit because they now have something that they can go and research. At this point, they would go and review vulnerability databases looking for known exploitable weaknesses in Apache struts. You could look for vulnerabilities by simply googling vulnerabilities in struts 2. This leads us to a website called CVE Details, which contains a database of known vulnerabilities. We have highlighted the top risk identified by the ID CVE 2017-5638. This type of vulnerability allows remote code execution, which would allow an attacker to entirely compromise the server. Clicking on the ID gives more detailed information. I have focused on the risk and impact analysis to build on what was discussed earlier. This shows that successful exploitation would result in a complete loss of confidentiality, integrity, and availability. This is therefore the most significant impact possible within the CIA scale. Also note that authentication was not required. Put simply, this means that an attacker does not need credentials to exploit this, making it, of course, the maximum risk for something that is running on the internet. If, as a result of exploitation, there was a failure to maintain heavy machinery, there is also an increased risk of accidents occurring. That implies an impact to safety or preservation of life as discussed earlier. However, at this time, that metric is not available in common risk analysis tools, so it has not been covered within the CVE database. Now that we have a CVE ID, we can again use Google to find publicly available exploit code. There are several available. For this demo, we're going to use Strut's own. Here is an SSH session which represents the attacker on the internet. I have downloaded the exploit from GitHub as shown, and now I'll use the check flag to confirm that the dashboard is vulnerable. Whew, the demo gods be praised, our server is vulnerable. The script also allows us to execute OS commands we want with the --cmd flag, so here I'll pass it the ID command, and as we can see, it is running as uid0, which is root. This is the highest privileges on Linux, so the attacker has gained complete control over the target. At this point, the attacker would want interactive command access. To do this, they would seek to establish a reverse shell. This works by starting a listener on the attacker's server, which is this SSH session, and then executing a command on the target, which communicates to the listener. First, I'll use the tmux command, and then I will split the screen vertically. Next, I'll establish a listener on the right using netcat -lvp 9090. meaning that it is listening on TCP port 9090. So now I'm going to use the strut's own exploit. This time it's going to run a command which is bash -I, an interactive command, and then it basically establishes a connection over TCP back to port 9090, which is our listener over here. So the attacker is sending this exploit, and the attacker is going to be catching the reverse shell. And that worked. So if I go over to this shell here, it's not terribly functional. As it says here, there's no job control, and I haven't got any sort of nice tab completion or anything. So there's a little bit of magic to update that. You do this little line of Python, it gives you a slightly more interactive shell. You do Control Z to send that to the background. You execute this command here, stt space raw dash echo. We send that one in. We do FG to bring the command back to the foreground, enter a couple of times, and now we're golden. We've got a more, like, it's essentially like we have SSH. It's a much more functional shell. Excellent. At this point, we have full control over the dashboard server. An attacker could explore the network that it is connected to and look for additional hosts to attack. That's pretty common. They can definitely access any data stored on the server. This will include source code such as the dashboard application itself and any other secrets that are on the machine. Those can be valuable. They can also trigger a denial of service by simply destroying the file system and making the server inoperable. So they have all those options open to them. But given the role of the dashboard is to warn the operator when they need to go and do some maintenance, I've got a more nefarious purpose. So if I go into the correct folder, I can alter how the dashboard works. I happen to know that the folder is /opt Tomcat, web apps, static, and images. You know, it helps when you've helped to build the vulnerable platform. What we've got here is the green and red images equate to the green and red images that were shown on the dashboard. If you can remember back to the start, green is when everything is fine, red is when everything is a problem. So if I take a copy of red and I make it like red dash backup, just in case I do anything wrong. And then what I do is I take a copy of, I can remove the red.png file so it's gone, and then I can copy green.png to red.png. So some people might be a few steps ahead here as to what's just happened. Ooh, goody! Suddenly a fancy shot. So the Android phone here has the sensor app installed on it. It equates to the top sensor with the description Cyber 2020 on the dashboard. And now because we've replaced the risk icons, no matter what happens, when the app is alerting, the dashboard doesn't really alert. So you'd have to blink and miss it because it does. The icon does change. It hot swaps the green with the green though, so it's hard to actually spot the status changing. So if we try that again. Yeah, it doesn't. It's really hard to spot. So I mean, if that was the sole means for alerting the operator, then obviously we've just circumvented all the protection that this monitoring solution has provided. It's not a very well engineered solution, we'll point out, and I'm sure you're all better at building things than we are. And that is how it is done. Attackers just find these dashboards or whatever on the internet. They then found an error message that they could learn something about the platform. They found an existing exploit, compromised the central infrastructure. The chances are your organization is not going to be attracting a 0-day threat, which means that the vulnerability is unknown. Therefore, your most likely exposure is by some piece of software going outdated, which you could mitigate by applying patches. That exploit was not picked at random. It turns out that was the exploit that was used essentially in the Equifax compromise of 2017. That was a major data breach which had major implications. As a result of that data breach, the Equifax were given a fine of up to $700 million in the wake of it. It's because their business is involved in handling and processing significant amounts of users' personally identifiable information, and the sheer scale of the amount of information that was leaked has led to an enormous fine. Those are the kind of threats that face you if your device or your ecosystem process personally identifiable information, medical information, all those things. Previous data protection legislation was a bit toothless in the modern age. You now have to contend with GDPR, which definitely has teeth and will bite you if there's a breach. That's all well and good, Paul, but there's a big question. How do we solve it? That's the question. And I think you need to do a bit more of security engineering in your products. You need to engage with standards, and they're coming out all the time. So there's an ISO standard, there's one from the EU, there's lots of things that are legislation backed that are in the wings in various places around the world. But I've had to just grab one, and I'm recommending the UK government's Code of Practice for IoT in consumer products. Others are available. Find one that works for you, stick to it. A standard is a good thing. Here's a high-level slice of that Code of Practice. It's covering quite a lot of the vulnerabilities that we hit out on earlier. Like I picked 4 before that are common. The very first one, no default passwords. That is how key it is. It's the very first tenet of this Code of Practice. Implement a vulnerability disclosure policy. I'm all for. What they mean here is they mean making a clear, identifiable way to contact you if a security researcher finds a vulnerability in your product. You don't have to pay them money. You don't have to get the problems hushed up. What you want to do is encourage people to be able to submit bugs to you so that they're not going to get prosecuted, and then you can get a whole bunch of free pen testing, really. Essentially, that's what you're talking about. And I would give you an absolute word of caution. Whatever you do, if a security researcher approaches you and has a vulnerability, do not dismiss it. There's an awful lot of high-profile cases where the researcher then goes on Twitter, it ends up in the news, all that kind of stuff. Always triage every vulnerability to its fullest, even if you think it doesn't exist. Get them on a call, treat them well, handle them, and basically you'll have a much better time. But if you don't implement a vulnerability disclosure policy, it's kind of the Wild West. The researcher can't find who to contact you, so they might just post it straight on the internet, and then you have a 0-day problem that you've had no time to prepare for. If you implement a vulnerability disclosure policy, you're going to have a heads up. And of course, keep software updated. The demo was all about that, was showing you that if you let things go out of date, then you're going to have a big problem. So what would I encourage you to take away from this? What should you do when you're moving forward? I should encourage you to introduce security in design and development phases. Test it throughout them, and not just immediately prior to launch. You definitely want to get your engagement with a security provider if you're going to go that route before you set up your supply chain and before you order millions of units. Definitely before those units are on retail. Because the second that you put something out there, if it's a consumer product, a security researcher is going to buy it if it's inexpensive enough. They're going to take it apart, they're going to pull it around, and they're going to find all the vulnerabilities. And if you don't have the disclosure policy, you're going to have potentially issues where the research just publishes it. You also need to understand your threat model, understand the data that it is holding and where it holds it and how it stores it. That way you can target your security budget. Definitely target your budget at the highest impact and most likely avenues of attack. Don't waste money on theoretical risks. Align to a security standard. Pick one that works for you and stick to it. Provide update functionality. For me, this is always a key one. That's why I keep coming back to it. Is because if your product has no ability to be updated, once again, then it can be obsoleted by a vulnerability being found in it, and that's an expensive waste of time for the consumers and for yourselves. And that is us out of time. I'd like to thank you very much for letting me speak to you. I've enjoyed myself. I hope you've enjoyed yourself too. If you need to get in contact, that's my email address, and there's the Twitter addresses for my company, and then myself down there at the bottom. Thank you. Oh, you're really very kind, guys. Thank you. I haven't got anything more prepared. That's it. I've got this one thing. Okay. I know you didn't really ask for an encore, but I cut all the ums and I cut all the ahs out of my talk, and I basically found about 5 minutes in my runtime. So I'm not even going to fill that with the encore. We're going to get you to an early lunch anyway. So just the other week, I was asked to do an internal training course for our sales team regarding our IoT service line, or what we call it, product service line review. And rather than make a proper slide deck, I basically wasted my time making this little video. What is the Internet of Things? The Internet of Things is a system of interrelated computing devices, mechanical and digital machines, provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. That quote was taken from Wikipedia. Or IoT is basically this. I am smart. I can order milk when you run out. I can call you if my power supply is interrupted. I can do your taxes. How can I help? Gives food. Gives a pepperoni. Access denied. You ate before. You ate before. You ate before. I mean, it's cringy, but I kind of like it, and I hope you got a little kick out of that too. The whole point of that was basically to sound as dull and boring as possible before the stupid video played, because we had a couple of new salespeople join, and they basically were told, you're going to get in training from Paul. It's going to be an experience. They'd all bigged it up somehow, and I thought I'd circumvent that. I'd subvert that by basically starting off the very first slide with the really drone, monotonous voice for the definition of Wikipedia, and then they wouldn't be expecting it. It didn't really work because the video didn't play. So you had no choice, but thanks for indulging me.